We talked a little bit about linear programming in class. This example is meant to support what you've learned. From the problem statement, you can see that glazed donuts are the number of them sold, G, and jelly donuts are the number, J, sold. A couple other things it says is a customer wants to buy no more than a dozen donuts. So this is a constraint. And it's an inequality. So the number of glazed donuts plus the number of jelly donuts is less than or equal to 12, which is a dozen. The next highlighted piece wants to try at least one of each kind, means they're going to purchase G to be greater than or equal to 1, and jelly would also be greater than or equal to 1. We don't know how many, but they're buying at least one. Next, we think about what the baker is really trying to do. They're trying to, or their objective, is to maximize profit. And so their profit, they say, is equal to 15 cents, so 0.15, for each glazed donut. So that would be times G, plus 40 cents, or 0.40, per jelly donut, J. The next thing we're going to need to do is to graph the constraints found up here, find the feasible region, and find intersections. With those intersections, we will then put them into the profit function to see which one is the largest. So it looks like we're going to need something as big as 12. If we look at our intercepts, when we sell 0 glaze, we'll sell 12 jelly, and when we sell 0 jelly, we'll sell 12 glaze. So this would look like this kind of line, less than or equal to, so it's a solid line, and we're going to shade below the line. I made the x-axis my glazed and the y-axis my jelly. It doesn't matter. We know that glazed must be greater than greater than or equal to 1. And so this would be 1. Greater than that would be going that way. Jelly would be also greater than 1. Greater than or equal. So this is going to be going this way. And so the region that works with everything is less than the diagonal line and larger than the vertical and horizontal lines. And so in this case, by inspection, you can pick out your intersections pretty easily as 11, 1, 11, and 11, 1. And obviously an intersection here at 1, 1. So we're looking at glazed equals 11, jelly equals 1, or jelly equals 11, glazed equals 1, and we have a profit function that says our profit will be equal to 15 cents times G plus 40 cents times J. You may be able to tell which is going to work, but I always try both because sometimes I can't tell. So in this example, I'll put 11 here and 1 here and come up with an answer. And the next time, I'll put 1 glazed, 40 cents times 11 jelly, and hopefully you can see this is the function that will actually maximize because we're multiplying 40 cents times a larger number. And as I suggested, because we're multiplying 40 cents times a larger number, we can make 455 for one combination and 205 for another. And obviously, anything in the middle of this region would represent other possible profits, but the intersections will be the greatest.